Adele, there's a problem when Curdy understands better than you.
Wait.
Big problem. Oh, Curdy. Stephen B. told me yesterday he saw your car parked in 2 parking spots. Yeah. Yeah. He said 1 parking spot, and then Curdy. You need 2 spots? You should be ashamed of yourself.
You probably thought it was a handicap.
Yes. Yeah. Oh well, you know, no right turn, double yellow. They don't mean anything to them.
It's this one. What do you have?
This one, you got this.
No, I don't have this one.
Ah,
I wasn't here.
They weren't.
no, but this was part of the. Oh, it doesn't matter. I'll just write it down. I'm drawing the diagram. Okay, so you've got this circuit here. Now, in this circuit, these 2 are resistors, this is a battery, and these 2 are lamps. But the problem with the lamps is that it doesn't list its resistance. If you look at the diagram, what you have instead is this. It says it's 4 volts and 12 watts. And here, this is a 12 volt and a 6 watt lamp. And we don't want this. We want the resistance, the or, like in these ones here. So, do we have any formula that links together what letter is watts? Is it current, voltage, or power? Is power. Power. So, power equals, and I think we have this formula, I squared or.
Yeah, it's like IV and to the V's or.
Yeah. But this isn't too great because we don't have the I, we just have the V. But we can also have this rule, V equals I or. So what does the I equal? I equals V over or. So I can put that into the power. And I'll get power equals V squared over or squared or. Well, that will cancel the square and you end up with this result here. Power equals V squared over or to write it the other way around, or equals V squared over P. Now, this is not in the formula book. This one here is in the formula book, and this one is in the formula book, and you need to put them together to get this. So, V squared divided by P. So, 144 divided by 36. What's that? I don't know if it's. I don't think it's exact. Can you give it to me as a decimal?
144 divided by 36.
Yeah.
4.
Is it? Oh yeah. Sweet. 4 ohms. And then this one here would be 16 divided by 12. So that's a decimal.
4 over 3.
So 1.33. Okay. Ohms. So now it's not so bad. Now all you really have is 1 battery and 4 resistors. So what rules do we use here that help us a lot? What are the name of the rules? There's 2 rules.
The weird Russians.
Weird Russian guy.
Kirchhoff's law.
Yes, close enough, yeah. Kirchhoff's.
Kirchhoff's?
I don't know, that's how my math teacher used to say it.
Stoffel.
Yes. Kirchhoff's 2 rules. So, the Kirchhoff pastry, is it? Okay, so I will just clean this up a little bit. So, I write down what you need to write down, but I want to clean this up, this diagram. Did you write this down? So what I'm going to do is I'll just get rid of these calculations here. Come on.
It's terrible rubber.
No, see the thing is they're making it too realistic. You know what I mean? Because
Yeah.
it's supposed to be a drawing program. But I don't want to blur it. I actually want to delete it. Alright. So this was 1.33 and then this one here was 4. So let's draw the current. Remember my advice. You start with the biggest battery and go with the battery. So here would be I1. I'll do a different color. I1, and then here of course would be I1, and then here would still be I1. But then what happens here? It splits. Oh, and by the way, it's I1 going into the battery as well.
Yeah.
It splits here, so here will be I2 and all the way down is I2. Yep, good stuff. But then this one here will be I3, and then I3. Okay, so what rule shall we use first? We shall use Kirchhoff junction rule. So if you look at this junction, what's going into the junction?
I1.
And what's coming out?
I2 plus I3.
Yeah. Should equal 0.
You put I2 in twice.
Right there. If you look at this junction, you'll get the same equation, so I won't bother looking at it. It'll just be opposite signs, so we'll forget about that. So that's the junction rule, J for junction rule. Okay, now let's look at the loop rule. I will look firstly at this left loop here, okay? So again, what do we start with? Start with the battery. So what's the voltage of the battery?
36.
36. And then we go across. We lose voltage when we go through this resistor. What's the voltage? V equals
I1.
IR. So we have minus
I1 or
I1
R1.
R1. Then we go through the junction and through here, and it'd be minus
I2 or
I2 R2, and then minus 1.33 I2 equals 0. That's that's a loop rule. Loop. There's another loop. You might want to look at this loop, but I feel like this loop here will be a bit confusing because there's no battery in it. So what I'll do is look at the outside loop, the outside. So if I look at the outside now, I have 36 minus I1 or 1. Then I go across to here, minus 4I3, and back here equals 0. So that's another loop. Okay, what's the situation? I have 3 equations, but how many unknowns?
3.
No, it's worse than that.
No, it's 4.
It's 5, because it's R1 and R2.
Yeah, oh, yeah.
Now, we're told though, calculate the current taken by each lamp when operated normally. By considering the total current in R1, so that lamp Q can operate normally with 12 volts across it, calculate the value of the resistance in R1. Okay, so calculate the current taken by each lamp. Oh yeah, okay, so the first part, that's actually a separate problem here. I'll go back to this, but I'm just going to the side for the moment, okay? The first part here was something separate. They just said, if you have this lamp, which is 4 volts and 12 watts, and then you have this lamp here, which is 12 volts and 6 watts, they want to know if it's operating fully at the 12 watts, what's the current? Now, do you remember the formula for power? Power equals
IV.
IV, and power equals IV. So the I here would equal
Like
12 over 4,
yeah.
3. And then the I here would be P over V, 6
half.
over 12, a half. Yeah?
So that's I3.
No, this is where you have to be careful, okay? This is where you have to be very careful. This is why these can be confusing. If I plug this is 100 watts. If I plug this into a small battery, will I get 100 watts coming out? Of course not. It can't be with a small battery. That 12 watts and that 6 watts is what it could do if it was operating normally. But it doesn't mean it has to be 12 watts. It just means it can be up to 12 watts. And then after that it might blow. Okay? So it's not necessarily the I2 and the I3. Not necessarily. Okay? Are we happy? We understand what I'm saying?
Yep.
Do we? Good. Now, part 2. Lamp Q operates normally. Now, we know lamp Q operates normally. Lamp Q was this lamp here. So if it's operating normally, he tells us this, we know that the I3 is, this is the Q one here, 3. So there we go. We still need to calculate, we can calculate the OR1. Do we have enough equations now? How many unknowns do we have? We now have
I1, I2.
I1, I2, R1, R2. So we need another equation. I think maybe I will take the loop here. Okay, I'll start here at this junction. So I start off with 0. I go around, and then what happens here? I lose minus 4 I3.
3.
Oh, that's great.
Minus
3. Yeah, go around here, and then what about here? Is it a plus or a minus?
The other way around.
I'm going around this way. It's plus because you're going backwards through the current. See, it's going down here. So it'll be plus 1.33 times I2 plus
0.
this one here as well. I2
R2.
R2 equals 0. That's another loop one. Okay, so, oops. How many equations now? 4. How many unknowns? 4. I1, we know I3. I1, I2, R1, R2. So you should be able to solve it now. So what I'm going to do is, I'll solve it in derive, but can you just write the 4 equations down? So did you write them down? No, I got a nice blank piece of paper there.
I don't want to start like revision now. I have to write it first.
Start writing Avenue.
Alright.
So I'm going to replace the I3s with 3. So here, that's now a 3.
Wait, how did we get 3 again?
That was the side problem at the start. We were told that Q operates normally.
And you said Q was the one to the very right.
Uh-oh. It's a half then, is it?
It should be.
Alright, thanks. That would have saved a lot of pain later. This here is a half. A half. Is there an I3 in here? No. I3 in here? Yes. A half. I3 here? No.
Is it a 3?
Where's there an I3?
4 multiplied 3 is 4 multiplied half. And the last one.
Oh, this one here should be a half. Thank you. You know, I don't think I need to rise. Everybody look up. Look. This one here, I can rewrite it to get I1, can't I? So if 4 times a half, 2. 36 minus 2, 34. And I take this over to the right, so I get 34 equals I1 or 1. And he wants the or 1. So anyways, what I could do is I could say I1 equals 34 over R1, and then I could put that into here. Actually, no, I don't even have to do that. I1 times R1, that equals 34. And look what you have here. I1 R1. So that's 34. Ah, but you still have an R2 here. Alright, I'll just use derive.
Oh,
What?
I thought we weren't going to use zero.
Alright, we won't. Wise guy. Right, let's at least clean them up.
Sure.
So I1 minus I2 equals a half. Unfortunately, that's stuck. It's broken. I1 R1 plus I2 R2. Is that a 1? Yeah. Plus 1.33 I2 equals 36. This one here, I1 R1 equals, that was the 34. And then the one at the bottom was minus 2. So 1.33 I2 plus I2 R2 equals 2. What's wrong, Curdy?
She got me inside here.
Can we try to stay focused on this? Alright, I know it looks a little bit messy or a little bit difficult, but it's not too bad. Before we solve it, we need to plan what we're going to do to solve it, okay? So here I have I1 and I2. So I could change I1 to I2 or I2 to I1. Here's R1, R2. Here's R1. Here's R2. So what would be the best way to solve this? Well, let's see what he's looking for. He wants R1. So I feel like I should get rid of I1 and I2. So what I could do is I could put this one in here for I1.
Or we can replace I1 R1 in the second equation, as in this way we'll have I2 R2 and the first
Replace this
equation.
one here.
Yeah, so this equation will only have two variables. And
I2
the last equation will have
R2.
two variables.
Ah, beautiful. Well spotted, Avenue. So we'll put this one into here, and then we'll put these two together. So we'll get 34 plus I2 R2 plus 1.33 I2 equals 36.
We just stuck with the same thing.
Is it identical? No, it's not.
We don't have I1 R1.
And then this second equation here is 1.33 I2 plus I2 R2 equals 2. Now, how many equations here? 2. And how many unknowns? 2. So you can solve these normally. So,
See, if you bring the 34 to the other side,
uh-oh, he has a point.
same thing.
Way to go, Avenue.
I just give suggestion, you did it.
Alright, well
What should I say?
before I try to solve it, let's check that there is an answer. So I'll put it into derive. So, do you have the equations written down?
Yeah.
Okay, so to make it easy for me to type in, I1 can be X, I2 can be Y, I3 can be Z, and then R1 can be A and R2 can be B. Alright, call them out to me. What's the first one?
X minus Y
X minus Y
minus a half
minus a half
equals 0.
equals 0. Next one?
36 minus X times R1, that's A,
Yep,
minus Y,
yep,
B,
yep,
minus 1.33,
yep,
Y
yes.
equals 0.
Looks okay?
Yeah, that's one.
Okay, next one?
Plus or minus?
For which?
Minus UB.
Is this
Minus
Minus
or-
Y, B. It's minus, I guess.
I think it's plus.
minus, 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 minus,
Yeah.
minus, minus. Plus doesn't come until the end. He's okay, leave him alone. Now, what's the next one?
36
Yep,
minus X A
X, yep,
minus 4 times a half, so minus 2.
yep,
Equals 0. Yes.
equals 0.
Yeah.
Okay, next one?
0 minus 4, no, 0 minus 2, so it's 4 times a half.
Yeah.
2, plus 1.33
Yeah.
y
Yeah.
plus yb equals 0.
All right, derive. Do your magic. No. It can't give an answer, so it means we're missing an equation.
Who's over now?
Huh? I will come back to this one. What?
Was it because I was falling asleep?
Were you
You
falling
were
asleep?
like, this area.
I know.
Oh, Brendan.